case may be, we are back and better than ever. And today, still spinning the tunes from Dave's Fave CD, top seller, produced by the great Darby Foster. Today, we are listening to Warriors Beat Warriors song, something Warriors, I forget, by Volbeat. I'll get that to you in a second. For now, let's go ahead and go with the cosine rule. Okay, so here is the cosine rule. I learned it as the law of cosines. It involves the sides and angles of a triangle. So in any triangle, these relationships occur. These relationships occur, and we can use them to solve for missing parts of a triangle. You may also be familiar with the sine rule here. It's much easier, it's easier to deal with, but there are some intricacies there that we'll discuss when we get to it. This is what appears in our textbook, and here is how it appears on our formula sheet. So they have all possible iterations, but that's not going to be available to you. You're going to have to learn how to manipulate it this way or that way. If you look, it's fairly simple. If I want to find the length of a side C, I square and the sum of the other two sides, subtract twice the other two sides, multiplied by the cosine of the angle C, the side opposite of what you're looking for. Look at that relationship. Those are the only times that those two letters appear. And here, conveniently, we have the equation solved for cosine C, although it shouldn't be that big of a problem for us, so that we can use when we're going to use the cosine rule to find an angle. That way we don't have to do all the algebra involved in finding that. Very nice proof here. It is in our textbook. It's fairly easy to follow. I encourage you to pause here and read through it. Of course, we will talk about it in class as well. We will go through it, but I think it's a good idea for you to go through it. So, okay. We can use the cosine rule. It's best used when we have two sides and an included angle. You'll see that in a second. Or if we have three sides and we're looking for an angle. Usually you want to use the sine rule if at all possible, but the cosine rule is powerful, and we'll talk more about that when we talk about the sine rule. Okay, let's get to it. This is very straightforward. Find correct to 2 decimal places the length of BC. This is what many of my former students, certainly not you, would call plug and chug. We're looking for side BC, which is actually little a in this triangle relationship. So if you look at our formula, it starts with a C, and there's an A, B, and a C. Oh my gosh, it's so confusing. Well, it's really not, because it's the side and the angle opposite it, and then you use the other two sides in the formula. So in this case, I mean, you could totally rewrite it very simply. A squared is equal to the other two sides, the sum of those squared, b squared plus c squared, minus 2bc times the cosine of the angle opposite the side that you're looking for. Actually, it's just the same letter, just capitalized to represent an angle. So it's really very easy to follow. And in fact, in order to find A, you might as well do this now. It's equal to the square root of all of this good stuff. And that'll just save you, I don't know, if you write it this way right away, it saves you one line of writing, perhaps, and when you crank it in your calculator. So A, in this case, would equal the square root of 11 squared plus 13 squared minus 2 times 11 times the cosine of 42 degrees. And you know what? I encourage you just to leave it like that. I mean, I'm very comfortable that 11 squared is 121 and 13 squared is 169. But you have a very nice calculator that looks exactly the same as what you have written. So why not use it? Control square root 11 squared plus, oops, equals, that's not good, plus 13 squared minus 2 times 11 times 13 times the cosine of 42. And, ooh, I'm in degrees up here. But if I was in radians, if it said RAD, I could always go here and put in the degree symbol. I'll put it in anyway. It doesn't hurt. I mean, just to show you where it is. Bam. Non-real calculation. Now, when that happens, you need to look and see where you might have made an error. Don't panic. And I don't know if you noticed it, I did not square my 13. So what happened is this became the square root of negative number. So if I go up and hit enter and just do it again, everything's going to work out swimmingly. Okay, so let's take a picture of that and put that A is approximately equal to 8.80 centimeters. Very good, very interesting. All right, let's move forward. Bam. In triangle ABC, AB equals 7, BC equals 5, and CA equals 8. So let's draw it. Find the measure of angle BCA. I'm going to change that because it's already solved for C. So let's change that to angle ABC. So we get some practice with the formula. Okay, so it doesn't matter if your triangle's not to scale, it just gives you a sense and makes it easier to follow the formula if you do a quick sketch. ABC, AB is 7, BC is 5, and CA is 8. Okay, and so the cosine, this is the formula if you want to use it this way. Cosine C equals A squared plus B squared minus C squared over 2AB. So look what's happening here. Whatever you're taking the cosine of, it only appears again when you're subtracting it. So you're going to use the other two numbers. You're going to add those and divide by twice their product. Okay, so I can say here that cosine of ABC, which is essentially angle B, is equal to, and I'm not going to use the number opposite, I'm using the numbers that are included, 7 squared plus 5 squared minus 8 squared over 2 times 7 times 5. So just look at the relationship in the formula and then you can repurpose it. If it really bothers you, you can change the letters like of your triangle to PQR. You just got to be very careful and manipulate it so it works out, so that's the angle that you're looking for. Okay, so angle ABC is going to equal the arc cosine or inverse cosine of 7 squared plus 5 squared minus 8 squared all over 2 times 7 times 5 right there. And so we'll crank that in our calculator. Let's see. And in fact, you know what? Really, when you're looking for the angle, you should write it out this way to begin with, because just to show your work, if I'm looking or the IB is looking for you to show your work, you can skip this step, save a little time, and write it immediately like this. Okay, so arc cosine, so trig, arc or inverse cosine. I love the little fraction bar, and I have a fraction, so I'm going to do it. So I'm going to do 7, hopefully I'll remember the squareds, plus 5 squared minus 8 squared all over, and what is it? Oh, 2 times 7 times 5, right? Yep. 2 times 7 times 5, boom chugga-lugga-lugga. So we can say that angle ABC to 3 significant figures is approximately equal to 81.8 degrees. Okay. Now it says find the exact area of triangle ABC. So exact means we can't use this rounded figure. So how do we do that? All right, well, area equals 1/2 AB sine of C. Okay, sine of C. Well, again, you have to look at, we're not looking for, we don't have sine C, we have sine B, so you just have to look at how this formula works. So area would be equal to 1/2. I have angle B here, right? So I have to use the 7 and 5. So it's 1/2 times 7 times 5 times the sine of 81.8 degrees. Now I just realized I thought this is actually the exact number, but since I changed the angle and the original problem, it came out perfectly, and we had to. It came out as a part of our unit circle, so we would be able to get an exact answer. But here we can't. So I'm just changing this to find the area of triangle ABC. But as it was written before, it was going to be a value that's on our unit circle, and we could have found the exact area. So if we crank that in our calculator, so 1/2 times 7 times 5, and you can also type in sine, by the way, and it'll pop up like that, but you got to do parentheses. 81.8. This time I won't put the degree symbol in because I know I'm in degrees. Enter, and there we go. The area of the triangle is approximately equal to 17.3 rounded to 3 sig figs. And what units are we in? Centimeters, so that would be square centimeters. Okay. That was awesome. Hope you enjoyed it. I know that I did. We are going to go out. The song I found out is A Warrior's Call. Warrior's Call by, hold on, let me find it. Volbeat. All right, there it is from Dave's Phase. Let's go out with that. And with that, I am out.